Hello and welcome back. In this video we're covering 8.4 on the area of a triangle using some trigonometric methods. So we've been solving side lengths and angles in the triangle using the law of sines and the law of cosines. So we'll be able to use some trigonometry to also solve for the overall area of the triangle, or the area contained within a triangle. So let's recall sort of a standard equation from geometry that the area of a triangle is 1/2 times the base times the height. So if we have some triangle, we'll call this base, call this the height. Or if we have a non-right triangle, it would still work out. We have the height here, and this whole side length would be the base. So let's use that as a starting point. So we have our formulas here, but let me draw out our situation. So let's imagine a non-right triangle. So we can call this the base. That means this distance would be the height. Let's call this angle C, and let's call this side length A. So we can say that the sine of C, the sine of angle C, is opposite over hypotenuse, imagining this triangle here. The opposite side length is the height of the triangle, and the hypotenuse is A. So if we solve this for H, we can say the height of the triangle is equal to A times the sine of angle C. And let's recall, they like to use K for the symbol for the area of a triangle. It's 1/2 base times height. So if we just replace height with this expression that we have, we can say K equals 1/2 B times A times sine of C. And they write the A first. So A times B times the sine of angle C. So we get our formula for the area of a triangle. Where we don't know the height of the triangle, sometimes that can be hard to find, but we can use side lengths and angles. So that's our first definition here. And there's two similar definitions using other angles. So we'll pick the one that works best for us. All right, so let's just practice using this in an example. It says find the area K of the triangle for which A equals 8, B equals 6, and C equals 30 degrees. So A is 8, B is 6, C is 30. So our area K, we said, is 1/2 A times B times the sine of angle C. So that would be 1/2 times 8 times 6 times the sine of 30 degrees. So that's 1/2 times 8 times 6. The sine of 30 degrees is 1/2. So that looks like 8 divided by 2, so 4. 4 times 6 is 24. 24 divided by 2 is 12. We don't have units, so I'll just say like 12 square units. So pretty straightforward, just need to plug into the formula, and depending on which angle we have, notice the angle is the one that is opposite from a side length that's not present in the formula. So if we're working with angle C, we had the other two side lengths in the formula. If we're working with angle A, we have the other two side lengths, B and C. If we're working with angle B, we have side lengths A and C. So that can help you choose which formula to use given your situation. There is an additional formula for the area of a triangle if we only know side lengths. If we don't know any angles, say we're unable to measure the angles in the triangle, but we just know the side lengths, we can use what's called Heron's formula. So this was a old school mathematician developed this formula, so let's put it to use. So this involves two steps. We have the general formula here, but it involves this additional quantity. If the side lengths are A, B, and C, we first have to find S, which is 1/2 of the sum of these three side lengths. And then once we have that, notice S appears in this formula. We can plug everything in and get the area of our triangle. So I'll keep these here and let's follow this procedure. We have sides. I'll say A is 4, B is 5, and C is 7. So first let's find this quantity S. It says that S is half of the sum of all of these side lengths. So 1/2 of 4 plus 5 plus 7. Well, that's 1/2 of 16. So S is equal to 8. So now let's plug into our formula. K is equal to big square root, where we have S, so 8, times 3 factors where we subtract each of these side lengths from S. So 8 minus 4 times 8 minus 5 times 8 minus 7. So that would be 8 times 4 times 3 times 1. So 8 times 4 times 3, that's 12 times 8. So K is equal to the square root of 96. So we want to reduce this square root. I can express 96 as 16 times 6. And the square root of 16 is 4. So that means that can come out as a 4 in front. And we still have 6 left over. So 4 root 6 if we want to give an exact value. If the question asks you to round, we could just evaluate it and round to whatever nearest decimal place it asks us to do. So in this case, if you're asked to find the area of a triangle, you're given only side lengths. You can use this two-step process. You want to find first this quantity S, and then we can plug it into Heron's formula. All right, this was a short section just exploring those two methods of finding the area of a triangle. So we did it with the side angle side triangles if we know an angle in two sides, and then for the side 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 triangle. Okay, that's it for this video, and I'll see you next time.